As we know by now, displacement, velocity, and acceleration are all vectors. What is special about vectors is that they have direction, which in turn led us to assign positive or negative sign to them to indicate direction. A negative sign simply means that it is acting in the opposite direction. But which direction is it really acting opposite to? Take for example, if you have a 5 Newton force versus a negative 5 Newton force. The negative sign here simply means that it is acting in the opposite direction to the positive 5 Newton force. But how do we know whether it's acting towards the right, left, upwards, or downwards? We would first need to know which direction is positive. This is where a sign convention comes in, which tells us which direction is assumed to be positive for a vector. If going towards the right is positive, then going towards the left is negative. If going upwards is positive, then going downwards is negative. If a clockwise rotation is positive, then an anti-clockwise rotation will be negative. In this lesson, we learn how to determine the positive and negative directions for displacement, velocity, and acceleration. The diagram here shows various motion of an object. We're interested to know the direction of the displacement, velocity, and acceleration in terms of whether they're going to be positive or negative. Let's first start with displacement. Direction of displacement depends on which side of the reference point or starting point that the object is at. In this diagram here, the reference point or starting point is given by this line. There will always be two sides, one on each side of the reference point, as we can see here. We will define the right side as positive displacement and the left side as negative displacement. Any object on the right side of the reference point will be having positive displacement. Meanwhile, any object on the left side of the reference point will be having negative displacement. This is regardless of whether the object is moving towards the right or left or speeding up or slowing down. What really matters is the side of the reference point that the objects were at. Moving on to velocity, direction of velocity depends on the direction of motion. For these four objects that are moving towards the right, their direction of motion is towards the right, so the direction of velocity will be towards the right. For the remaining four objects that are moving towards the left, their direction of motion is towards the left, so their direction of velocity will be towards the left too. Next, we'll compare the direction of velocity with our sign convention, which is established as rightwards positive. Velocity direction that is in the same direction as our sign convention will be positive. Velocity direction that is opposite to our sign convention will be negative. What really matters here is the direction of velocity compared with respect to our sign convention. It does not matter whether the object is speeding up or slowing down or which side of the reference point the object is at. Finally, moving on to acceleration, direction of acceleration depends on the direction of resultant force. It should be noted that resultant force causes acceleration and that the resultant force and acceleration will always be in the same direction. Let's look at the examples row by row. In the first row, we have the objects moving towards the right with their speed increasing. The only way they can have their speed increase is if the resultant force acts in the same direction of motion. Therefore, the resultant force and hence acceleration will be towards the right. For the second row, we again have both objects moving towards the right, but the speed decreases. The only way that the speed can decrease is if the resultant force acts in the opposite direction to the motion. In other words, it is opposing the motion. Therefore, our resultant force and hence acceleration will be towards the left. Moving on to the third row, we have both objects moving towards the left while the speed increases. The resultant force must therefore act in the same direction of motion. Therefore, the resultant force and hence acceleration is again towards the left. For the last row, both objects move towards the left while the speed decreases. The resultant force must be opposing the motion. Therefore, the resultant force and hence acceleration must be acting towards the right. Finally, to determine whether the acceleration is going to be positive or negative, we compare it with the sign convention again. If the acceleration direction is in the same direction as the sign convention, then it will be positive, just like the first and last row. On the other hand, if the acceleration direction is opposite to the sign convention, then it will be negative, just like the second and third row. One last thing to note is the common misconception that negative acceleration causes an object to slow down. This is not necessarily true. A negative acceleration may actually cause an object to speed up. Like what we see here, negative acceleration is actually causing the object to speed up. On the other hand, positive acceleration does not necessarily mean that an object will speed up too. It may also cause the object to slow down, like what we see here. A positive acceleration is causing the object to slow down. So how do we then determine whether an object is actually speeding up or slowing down? We would need to look at the sign of the velocity and acceleration. If both velocity and acceleration have the same sign, either positive positive or negative negative, that means that velocity and acceleration are in the same direction, therefore the object speeds up. On the other hand, if both velocity and acceleration have opposite signs, either positive negative or negative positive, that means that both velocity and acceleration are in the opposite direction. The object will therefore slow down. To illustrate this point, look at the examples that we have. When the speed is increasing, the sign of the velocity and acceleration are all the same, either positive positive or negative negative. And then when the speed is decreasing, notice that the sign of the velocity and acceleration are all opposite. So this is how we would determine whether an object is actually speeding up or slowing down.